Hey guys, this is Mr. Bullock, and this geometry lesson is on applying deductive reasoning, a little bit of law of syllogisms. Let's go ahead and take care of this board problem. Again, this is one of our lessons that, because I teach at a block school, is sometimes admitted just with time constraints, particularly the second term at our block school and state testing and stuff. So we just try to conserve time. Anyway, so write the converse of each true statement and tell whether the converse is true, and if false, explain why. Okay, so if x is, so here's A. If A, then B. So if x is greater than 4, then x is greater than 0. So the converse would be if B, then A. So if x is greater than 0, then x is greater than 4. And that's false because x could be some other number greater than 0 that's not greater than 4. Okay, so number 2, if x is less than 6, then negative x is greater than negative 6. Okay, so if we wrote the converse of this, then it would be if x is greater than negative 6, then x is less than positive 6. Okay, and that's true. Remember, when you multiply by a negative number, it flips that inequality. If I multiply both sides by a negative 1, it flips the inequality in the other direction. Okay, write a statement that is true but whose converse is false. So there's all kinds of statements. A statement that's true but a converse is false. Well, there's one right above I just showed you. So one I've been using: if I live in Sacramento, then I live in California, and the converse would be false. If I live in California, then I live in Sacramento, and that's false. Okay, apply deductive reasoning. Okay, deductive reasoning uses facts, definitions, and accepted properties to form a logical argument. Later, we're going to start dealing with proofs, and it's all about deductive reasoning. And so inductive reasoning is what we just got done with. It makes educated guesses. So it uses specific examples and patterns to form an educated guess, which is called a conjecture. Okay, the law of syllogism happens this way. If A, then B, and then it says if B, then C, these two have to match up right here. The hypothesis of the first statement must be, the conclusion of the first statement must be the hypothesis of the second statement. And so this says if B, then C, and if that happens, then I can say if A, then C. Okay, and these three dots means therefore. All right, so for example, if I live in Sacramento, then I live in California. Now notice I said here's the conclusion. Notice the conclusion is the hypothesis of the next one. If I live in California, then I live in the United States. Something brand new. It's it's not Sacramento or California. So therefore, I can say if I live in Sacramento, then I live in the United States. And that's true as long as you can accept if this is true and if this guy's true, then this one's going to have to be true. Okay, and I know there's exceptions to that, you guys. I'm sure if you Googled somewhere, you can find a different Sacramento somewhere else. But in general, the Sacramento I know is in California. It's the capital of California. Okay, if possible, use the law of syllogisms to write a new conditional statement that follows from the pair of true statements. Okay, so we're going to pretend like or accept these to be true. Okay, so if Rick takes chemistry this year, that's our A, then Jesse will be Rick's lab partner. That's our B. This one says if Jesse is Rick's lab partner, hey, there's your B, then Rick will get an A in chemistry. That's something new, so that would be C. Okay, so I did it in color codes right here. The blue is the A, the red is the B, and notice this is red again, so that's the B, and this is something new, that's C. Therefore, I can say if A, which is if Rick takes chemistry this year, then C, then Rick will get an A in chemistry. Okay? All right, isn't that fun? All right, so how about this one? If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. Okay, now these are just arranged a little bit different, you guys. If you can recognize, this says if A, then B, and this one says if C, then A, okay? Can you notice that this x squared greater than 25 is this x squared greater than 25? So I can put this conditional statement on top right here, and if I do that, then I notice the A's will line up, and then I can say as long as these line up, I can say if C, then B. Okay, so that's okay to do that if you can rearrange it. So if C would be if x is greater than 5, then x squared is greater than 20. All right, let's try another one. If a polynomial is regular, then all angles of the interior of the polygon are congruent. Okay, so regular would be A, and then angles interior congruent would be B. Okay, and this one says if a polygon is regular, that's A, then all sides are congruent. Okay, sides is different than angles, so that would be C. Okay, I don't see any way I can rearrange it because neither of the statement's conclusions is the same as the other one's hypotheses. Alrighty?